What we see in here is a regression output table produced in Excel for a simple linear regression to explain faculty score with only one predictor, the age of the faculty, and we assume the association is linear. Let's go over the basics of the output table one by one. Here we assume there is just one predictor, which is age of the faculty, to estimate average faculty evaluation score. And we assume the true relationship is linear. This is our model. And we don't know the true parameters, beta 0 and beta 1. We have just one sample, and based on what we have, we calculated our estimate of the true parameters. These are our estimates. And this is for the intercept, and we have the slope coefficient. And each time we have a different sample, just know that we will end up with different numbers. And we can write down the linear regression equation in this form. Here, intercept is 4.46 and slope parameter is 0.01, minus 0.01. What we say is that, like, if we put it in a two-dimensional graph to explain average faculty score with age, as you can see, slope is negative. We have a downward sloping slope, and the line will be something like that, where intercept will be 4.446. This is our intercept, 4.46, and slope of this line is going to be equal to minus 0.01. We know that regression equation will give us more information than correlation coefficient. We can easily quantify the association between our target variable and our predictor age in here. So how are we going to interpret slope coefficient estimate of minus 0.01 if age increases by 1 unit? Again, that unit can be in years, in months, in days. It's very important how do you measure age. So whatever that measurement, then if it goes up by 1 unit, the impact on our target variable faculty, average faculty score, since we have minus in here, we're going to see that it's going to go down by how much? 0.01 units. So faculty score will go down by 0.01 units if average faculty age goes up by 1 unit. Another important test statistics in regression output is the F-test. It is being used as an overall significance test for the null hypothesis that all coefficients are equal to each other and it is set to 0, pretty much saying that model is wrong. So how can we test this one? We are going to compare significance F with our level of significance alpha, which is generally 5%. So if our significance F value produced in our output is less than 0.05, what we're going to do, we're going to reject the null. Sounds like a bad thing, but in fact it's a good thing. We reject the null of no significance, which means at least one of them is non-zero. So if that significance F is less than 0.05, we say that model is significant. So we have a good model. We can move on and interpret the results. Another important statistics is the R-square value, also known as coefficient of determination. It will pretty much tell you the power of your regression model. This is the total variation in your model, and our regression model can only explain a very tiny fraction of it, pretty much 1%. On average, this model can explain only 1% of the total variation. This is not a powerful model, but sometimes you may end up having a very good R-square value. So that is how we interpret R-square value. Now I'm going to give you another example where we will pay attention to the unit of measurement. Now we have a different regression model. We end up with the following linear regression equation. Here Y stands for total sales, but unit of measurement is in $1,000. In other words, 1 unit in Y is equal to $1,000. On the other hand, our predictor is advertising spending, and it is measured in just $1. In other words, for X, 1 unit is equal to $1. For Y, 1 unit is equal to $1,000. Now, you can be asked about the point estimate for sales if a company is spending in a month like around $800. Here, since our X is measured in dollars, I can easily plug in X in here and then solve for Y given the intercept and slope coefficient. I end up with 2,540. Again, this is the unit. Okay, why we expect Y to be that much units? And I know that 1 unit in Y is equal to $1,000. So there is a predicted sales amount of that much units, and I know that 1 unit is equal to $1,000 in Y. I can just do the multiplication and I come up with this number. That will be the expected sales in dollars if a company is spending around $800 in advertisement. Again, this is in units, this is in dollars. You have to pay attention for the unit of measurements. Thank you.